Hey there, sound snobs. We have some testing to do today. Today I have a GIK, I'm not sure how they pronounce that, 244 5-inch broadband absorber. It's got about 3.5, maybe 3 3/4 inch of absorbent material, which I believe is fiberglass.
And we're going to be testing it against this dope panel, which is a hemp and recycled cellulose composite. It has a 3-inch hemp board frame made with hemp hurd and a non-toxic binder, which results in 2.5 inches of absorbent material. So just to recap, we have a 5.5-inch frame versus a 3-inch frame. And then 3.5 inches of fiberglass versus 2.5 inches of a hemp and cellulose composite. Here's the website confirming my measurements.
I'm using a UMIK USB mic into a MacBook Pro. I have the JBL monitor. It's a 3 Series 8-inch driver.
And here are the tests. The red line represents the baseline, which is just a frequency sweep from the monitor directly into the mic. The purple line represents the tone sweep through the GIK panel and into the mic. The brown line represents the tone sweep through the dope panel and into the mic. There is no way to accurately determine any reflective qualities. Now this is just a test, and it is not a representation of the unique and patented design of the GIK panel itself, only the absorbent materials inside. A panel on the wall has the advantage of absorbing frequencies on the way into the panel, as well as the remaining frequencies reflected off of the wall that the panel is attached to. This is how they can create greater absorption ratios at lower frequencies. The 1+ inch air gap created with the GIK panel is a simple and effective way to create a product that performs the best in relation to the amount of mass and materials used. This dope panel, however, performs very well, including at the very frequency 60 Hz that the GIK website advertises. These are impressive numbers considering the size of the waves both panels are absorbing compared to the size of the panel's surface area. Panel size and structure could still be a factor here. The width of the GIK is over 24 inches with a thinner wood composite frame, while the dope panel has a thicker hemp hurd and formaldehyde-free resin composite from the company Grove. This hemp board takes up more space, but could also aid in both absorption and deflection. More work needs to be done to understand the effects of the cross bracing, but for now, we should see these as rough tests, displaying the potential for hemp and natural fibers. The end goal is providing a potentially carbon-negative alternative to the labor-intensive and toxic manufacturing of mineral wool and fiberglass.